Hello, my name is Sung-Hoon, and first I'll show that it compiles without any errors. So there's no issues here. Next I'll show the 17 test files. So in the case of background process, we replace the last character ampersand to be null for the exec to be executed, and then if it has special symbols such as pipe or redirection symbol, we perform the related pipeline functions. Else we perform the program, and if there is any errors, we print the error message. And in the case of foreground, we don't perform this action and do the similar task. So I'll be talking about the eval, the waitfg, and the built-in command function. So starting off with eval, we first call the parseLine function to parse the arguments from the command line and store them in the arg_sets variable, is the size of max arguments. And then we call the built-in command function to check if the command is a built-in command that needs to be executed immediately. So here we check if the first argument is either quit, jobs, fg, or bg. In the case of fg or bg, it requires additional arguments to know the PID or JID. So if there is no second argument, then you just do nothing, return 1. And if there is additional arguments, we call to BGFG, which will be explained by another group member. So in either cases, it's going to return 1 if the first argument is one of the built-in commands. And so if it returned 1, we could just return from the eval function because it means the command has been executed in some way. Otherwise, it means that we assume that first argument is a path to a program to be executed as a child process. And so before adding the job to the job list or calling executing the program in the child process, we have to first block the signals. And so this is that. And then we call fork to create the child process. And in the parent process, we suspend the signals until we add the jobs, and then we unblock them. And in the case of foreground, we do the same, except that we have to also call the waitfg function. And this waitfg function it suspends the signal until the PID is no longer the PID of the foreground process. So it means that we wait until the foreground process is completed. So there's that. And in the case of child process, we set the mask back to the old one, and then we call set PGID to change the group ID for the child, so that the signals sent to the parent is no longer sent to the child process. And then we notify the parent that the child is ready, because we change the PGI the group ID. And